Hello everyone and welcome to another short tips and tricks video on Wallacei X. In this video we're going to look at how to visualize solution and really take advantage of the phenotype input when exporting from your simulation. So I'm just using the normal Wallacei X example file that you have in the downloaded zip folder when you download Wallacei X. And within this file, we should already have a Wallacei simulation that has been complete. So your icon should be purple. If you don't see the icon, you just need to go to display and click draw icons. That's what you're seeing by default. You can simply change that by clicking draw icons. So what I'm going to do is I'm going to construct a phenotype that is going to allow for better visualization of my results. So as it stands, my phenotype is down here in this yellow box and it's all disabled. I'm just going to enable these phenotypes, these components. I'm going to delete everything except for the extrusions. So if I just preview this geometry, so this is my phenotype. This is the geometry that I'm going to run the simulation on. And what I want to do is I want to do three things. I want to visualize the full geometry. I want to visualize buildings, or I want to be able to color buildings that are above a specific height. And I want to color the courtyards in the middle. And finally, I want to add some trees. So how can I do this so that I only need to do this once, and then every time I export my simulation, I automatically have all of this data in a nice and clean structure? So the first thing I'm going to do is I'm going to create a tree structure with all of this information. So to do that, I'm going to bring in the entwine component. So the entwine component, I'm going to input into these different streams here the various geometry that I want to then visualize after I export solutions from simulation. So the first thing I want to visualize is the default one here, which is the geometry, the buildings essentially. So I'm just going to bring a geometry component. You don't need to bring a geometry component. I'm just doing this for the purposes of making it clear as you follow the tutorial. And so here are my buildings. So the second thing I want to do is I want to highlight or only export buildings that are above a specific height threshold. And so these buildings are, I'm going to, let's say, deconstruct box. This is going to give me the X, Y, and Z components. And then for the Z, I'm going to simply deconstruct domain. That's going to give me the start and end. So the starts are always 0 because that's the lower domain of the box, and the end is the height. So I'm going to say that if any building is higher than or taller than, let's say, 20 meters, dispatch. And so I just want the buildings that are above 20 meters. And so technically, here are the buildings in green that are above 20 meters, and we can change this threshold maybe to a little bit. Let's say anything above 30 meters, for example. And so I'm just going to rename this buildings above threshold. And so that is my second input. I'll hide all of this information just to keep everything nice and clean. Right. The third stream that I want to input are the courtyards. So I just want to be able to color the courtyards in green or any color later on. So I already have the courtyards. If I go back into my definition, these are the courtyards here. So if I just get a geometry component, so these are the courtyards. I don't want the outlines. I want them to be surfaces. So I'm just going to get a boundary surface. So these are the courtyards there. Get another geometry component. And then I'll rename this to courtyards. Finally, what I want to do is I want to distribute trees. So this is just going to be an arbitrary thing I'm going to do. You can follow along or not, as you wish, but I'm just going to create a point in Rhino at my 0, 0 coordinates, so just down here. I'll just draw a vertical line, so I'll type in line. I'm just going to create a very generic, simple tree. So I'll pipe this with whatever kind of diameter, doesn't really matter. And I'm just going to add a sphere to the top of this line. And this is my tree. I'm going to bring this tree into Grasshopper. So set multiple geometry, select tree. And just to make our lives a little bit easier, and to also further kind of explain how you can really take advantage of the phenotype input in Wallacei X, I'm going to mesh join this geometry. So I'm just going to, rather than having, you know, two objects, I'm just going to have a single mesh that represents this tree, and I can hide this component there. What I will do is that I just want to quickly distribute this tree to the various courtyards. I'm just going to do a very quick way to do this. I'm going to take my courtyards. I'm going to populate the courtyards with points, just a random number of points. So let's say just 20 points per courtyard or whatever. And I will move with a vector 2 point. And so the initial point of moving is going to be that point that I put in 0, 0. So I'm just going to create a 0, 0 point. And the B is all the points in from the populate. I'll just put this, and that is going to be the geometry that I'm going to move. So that automatically kind of distributes trees all over my various courtyards. Obviously, all of them have the same distribution because they're all the same seed. So you can kind of change the seed if you like with a random component. Why not? Let's do that really quickly. So I'll randomize just from 0 to 100. It doesn't really matter. And the number of random seed values corresponds to the number of courtyards I have. So in this specific case, I have 9 courtyards. So I want 9 random seed values. And when I input that, all of the courtyards have kind of a random distribution of trees. Right, so this is my last input, and so I'll get another geometry component here. I'll rename this trees. Again, the purpose of renaming these components is purely for visual purposes, so that you can more easily follow along. There isn't another reason for this, and also maybe it's just to help you later on better understand which filter belongs to which tree. Right, so now that I have my phenotype set up, so my phenotype is comprised from my buildings, the buildings above a specific threshold, in this case we said 30 meters, the courtyards, and the trees. So what I will do next is I'm going to connect this to the phenotype in Wallacei. I'll double click the component. Again, because we already have a simulation that is run in the example file, you don't need to run the simulation. If we just go to Wallacei selection, the first step, as always, is to draw the parallel coordinate plot. That's going to activate all of these features down here. And then for now, I'm just going to select the Pareto front solutions. I'm going to click all, and I'm just going to select at random a few different solutions. I'm not really too concerned about how many solutions there are down here. I'm going to select a few, add them to my export list, and click export. So this is going to export these solutions. We'll just wait until this finishes. Right, export finished. And now I have my exported solution. So I'm just going to hide all of this information. I'm not really too interested about this or about this anymore. So as it stands, this is my existing phenotype, so to speak. And I'm not really too interested in the current one before the definition. Now we're after the definition. So how do I quickly get all this information back into these various branches to be able to visualize them in different ways? So just to kind of quickly look at the data structure that I created here. So this data structure, I have 4 branches. So the first branch is buildings. Branch 1 is the buildings above a threshold. Branch 2 is courtyards, and branch 3 is trees. So if I were to now look at my exported solutions here, I'm going to have 11 branches. Each branch corresponds to a solution that I exported from my Pareto front. So the first thing I want to do is I want to only visualize these one at a time. So to do that, I'm going to, because if I go to Wallacei tab, and if I go to the decode phenotype, what this will do is that it will decode all the phenotypes at the same time. And that's not what we want to see. I want to be able to visualize each phenotype at once, so one at a time. And so the best way to do that, if I disconnect this, I want to use the path structure here to be able to select different branches. So if I go down into tree statistics, what tree statistics does is that it's going to give me the paths as a list. So each branch, I'm going to get the paths as a list. Then what I can do with this list, I can simply list item, these paths. I'll create a slider from 0 to 10. And I'll type in tree branch. And what this is going to allow me to do is extract a specific branch from a list. So the list that I want to select from is the W phenotypes. And if I quickly just look at the output that I'm getting here, so currently I'm only selecting path 73, 0, so on. As I move the slider, I'm selecting various paths. And so now, rather than select all of the phenotypes at once, I'm only selecting one phenotype at a time. And so now if I input this into the W phenotypes, I can very quickly select a single phenotype and go through them as I need. So this is quite good. The next step would be how to kind of extract or go back to the tree structure so that I can visualize the various inputs with various colors or whatnot. So what we did down here was that the buildings above the threshold and the courtyards were all B-rep geometries. These were not meshes. The trees was a mesh. So when we use the decode phenotype component, you'll notice that the outputs are split into geometries, meshes, numbers, and text. This is just to make it a little bit easier for you to quickly extract various pieces of information rather than having to extract all at once. So if I look at the tree structure for the geometry, so this is how we are going to look at this path. So this path is comprised from branch, generation 76, individual 45, path 0, we're not really too concerned about that, and then the last branch, which is 0, belongs to buildings, which is this 0 here, 0, 0, 0, 1, 0, 2, and 0, 3. 0, 0 is the buildings, 0, 1 is the buildings above a threshold, 0, 2 is the courtyards, but where is 0, 3? 0, 3 is missing. And that's because 0, 3 is going to be found under meshes, because 0, 3 is a mesh, which is the trees. And here we are, 76, 45, 0, 3. So how do we extract this information? A quick way to do it would be to simply explode tree. If I explode the tree, right click and match outputs, I can quickly get the 3 various output streams. But I'm not going to do that for this approach, and I'll explain why in a second. So what I'm going to do, rather than explode trees, I'm going to split the tree using a mask. It's a little bit of a more tedious process, but it does save time and at the long term. So the tree that I want to split is this geometry tree, and the mask that I want to create is the following. So I'm just going to create a panel, and I'm going to type in curly bracket, because that's the first item, curly bracket. I'm going to put in question mark, because I'm not really too concerned about whatever is in here, that first item. So I'm going to say select any of these, semicolon, again, question mark, semicolon, again, question mark. Question mark says that it doesn't really care what the number is. It's just going to select all of the values in that first path, in that second path, and that third path. And then the last path is 0. So I only want this path here. So this 1, 2, 3, and 0. And if I close the path with a curly bracket, smaller, and what that gives us is that's going to give us only the geometry. Right. So I'm going to copy this 3 times. And all I need to change is that last half number. So I'm going to make that into 1 and that into 2. I'll hide this for now. So now that I have these various paths, I'm going to custom preview. Let's just kind of color them some nice swatches. So I'll color the buildings in white. I will color the buildings above a specific threshold, let's say in a saturated blue. And the courtyards, we'll color them, let's say, in a nice dark green. So these are my various outputs. The last one I'm going to do is the meshes. So again, with the meshes, you can do the same thing. I'm going to put the meshes there. And for the meshes, I want 3 because the path structure is 0, 0, 0, 3. And that's going to give me the trees there. And again, I will color these in the light green. A quick way to really visualize this in a nice way is if you go into your Rhino viewport and click on Arctic. And that's going to give us a nice visualization if I just hide that. And that is how to visualize the components. So the benefits of this is that I can quickly go through the various list items and quickly see the different buildings without having to export or color everything every single time. So now the question becomes, why did we use these paths here rather than simply explode tree, which would have made our lives a little bit easier? And the reason I didn't do that is because what if we want to visualize all of these geometries, all of these 11 geometries from here, all these 11 phenotypes at once using the distribute to grid component, which we have under the Wallacei suite down here, which is distribute to grid. And for you to use this is going to be much easier and quicker to use the split paths down here. So over the distribute to grid, I'm going to keep everything as it is. The only thing I'm going to do is I'm going to put fitness values up there and the phenotypes. If you don't know how to use this distribute to grid component, we have another video in a short tips and tricks video on how to use this. So I recommend having a quick look at it. So now that we have this distribute to grid component, obviously if I preview it, it's going to show me all of my solutions distributed, which is fine. However, I want to color them with the same colors as before. And the quickest way to do that is to simply input the geometry into each one of those. And because I'm not using an explode tree, rather I'm doing the paths, at this stage it doesn't really matter because I told it, using these paths down here, I told it to ignore the first 3 paths, so question mark, and question mark, and only select the last path, which is 0. And so in this specific case, it's only the buildings. And that is a very quick way to be able to visualize all of the buildings or meshes or geometry or whatever it is that you want to visualize at a quick and single button. The benefit of this, of course, is that you can always go back into your simulation and export other solutions. So if I clear the list, and let's say I select only 3 solutions, click export. And so now the benefit is everything is already set up. You can obviously always preview or show this geometry. Obviously, when you show this geometry, it's going to give us this information down here, but it's also going to highlight, because it's automatically displaying the geometry that you're already displaying using these components. A quick way to hide this but keep the text down here would be to simply go into your grasshopper command there and just make them transparent. And when you do that with a black color, it actually has that added feature of giving a nice outline around your buildings. And so that's basically it. I hope you enjoy this video tutorial. We will probably follow this tutorial with another tutorial on how to create animations using this exact same method. So we just move forward with adding another suite of components on how to create animations. But in the meantime, please play around with this approach and do send us the work that you're creating with Wallacei for us to kind of show on our webpage or our Instagram, and to really kind of show the world what Wallacei can achieve. Thank you very much, and stay safe.